Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2009, and so let's get right into it. First problem, one can holds 12 ounces of soda. What is the minimum number of cans needed to provide a gallon? 128 ounces of soda. Okay, so we can right away say that 128 ounces equals 12 ounces times 10 plus 8. So for the minimum number of cans, they have to be an integer, right? So 128 is less than or equal to 132, so this is 11 cans. The answer is E. Number 2, 4 coins are picked out of a piggy bank that contains a collection of pennies, nickels, dimes, and quarters. Which of the following could not be the total value of the 4 coins in cents? Okay, so since these are all multiples of 5, then none of the 4 coins can be pennies because they would make it not a multiple of 5. But then if pennies are out of the question, then the least amount possible is nickels, so it's 5 times 4. This is 20 cents, and so anything less than 20 cents is impossible. The answer is A. Number 3, which of the following is equal to 1 plus 1 over 1 plus 1 over 1 plus 1? So this is 1 plus 1 over 1 plus 1 over 2. This is 1 plus 1 over 3 over 2. This is 1 plus 2 over 3. This is 5 over 3. The answer is C. And problem number 4. Eric plans to complete in a triathlon. He can average 2 miles per hour in the 1/4 mile swim and 6 miles per hour in the 3-mile run. So for the swim, he will go. He will take 1/8 minutes, 1/8 hours, and in the 3-mile run, he will use 1/2 hours, and he wants to finish the triathlon in 2 hours, right? So time left equals 2 minus 1/8 minus 1/2. This is all over 8. This is 16 minus 1 minus 4. So this is 11/8. And so the bicycle ride is 15 miles, right? So it's 15 divided by 11/8, which equals 15 times 8 over 11. The answer is 120/11, so it's A. Number 5, what is the sum of the digits of the square of 111111111? Okay, so if you know already that this squared would be 1 2 3 4 5 6 7 8 9 8 7 6 5 4 3 2 1, then all you would have to do is say that there are 9 times there's 1, there's 2, there's 3 4 5 6 7 8 9 nines, so this is 9, so the answer is 81. You could go like this, but if you don't know this, then you could just say 111111111. It's multiplied by 111111111, right? So this would be 111111111 111111111 111111111 all the way until this is 111 all the way until this becomes 1111111, and then this corresponds to this line here. So there are 1 of this, there's 2 of these, 3 4 5 6 7 8 9 of these, and then it gets less. 8 7 6 5 4 3 2 1. This is another way that you could get this number, so anyways the answer is E. Problem number 6. A circle of radius 2 is inscribed in a semicircle as shown. The area inside the semicircle but outside the circle is shaded. What fraction of the semicircle's area is shaded? So for this problem, there are 2 ways. So we actually there's only one way. You could see that this is 4, since 4 is the diameter of the circle, and so the semicircle would be 1/2 times 4 squared pi minus this is 2 squared pi equals 8 pi minus 4 pi equals 4 pi. So the total area is 8 pi, but the fraction of the area is 4 pi, so it's 4 pi over 8 pi equals 1/2. But a good tip to know here is that when you've got two same squares, then the area of a circle that is completely inside the square, so the area of a circle that is inscribed in the square is equal, so the circle that's inscribed in the square, like this, so this is equal to the area of the quarter circle with this radius, right? So I'm saying that this area is the same as this area, and if you want me to prove it to you, then let's say that this is r, and since these, and so this would be 2r, so this would also be 2r, right? So the area of this is pi r squared, and the area of this is 1/4 times 4r squared pi, so this is pi r squared. So as you can see, the area of this sphere and the area of this quarter circle is the same. This can actually be pretty useful in a few problems, such as this one. So if you had known this, then you would have seen that there are two of these quarter circles, and this circle has the same area as both of them. So you could have just said that the shaded area is 2 minus 1, and then the whole thing is 1, so, and the whole thing is 2, right? So this could be 1/2. That's another way that you could find A. So keep this in mind. So this will be useful for you later, and the answer is A. So let's go on. Number 7, a carton contains milk that is 2% fat, an amount that is 40% less than the amount contained in a carton of whole milk. What is the percentage of fat in whole milk? Okay, so it says that 2% fat is 40% less fat, so this will be 60% fat. And so to make the numbers prettier, let's just say that the milk has 6 of fat, and the total is 300. That way this will be 2%, right? But then this would be 40% less fat, right? So a carton of whole milk would be 10 fat over 300 total, right? So the percentage of fat in whole milk is 10 over 300, and then it's a percentage, right? So you have to multiply 100. These cancel, so this is 10 over 3. The answer is C. Problem number 8. 3 generations of the Yuan family are going to the movies. 2 from each generation. The 2 members of the youngest generation receive a 50% discount as children. The 2 members of the oldest generation receive a 25% discount as senior citizens. The 2 members of the middle generation receive no discount. Grandfather Wen, whose senior ticket costs $6, is paying for everyone. How many dollars must he pay? Okay, so there are 2 from generation 1, 2 from generation 2, and 3, and 2 from generation 3, right? And so if the amount that so if the amount with no discount is A, then the oldest generation receive a 25% discount, right? So this is 3 over 4A, and then the children would receive 50% discount, right? So this is 1 over 2A, and the ticket for the senior citizens is $6, so this would equal 6. So this would equal 8, and this would equal 4. So how many dollars must he pay? There are 2 members in each generation. So 6 times 2 plus 8 times 2 plus 4 times 2 equals 6 plus 8 plus 4 times 2. This is 18 times 2, so the answer is 36. It's B. Problem number 9. Positive integers A, B, and 2009 with B is less than A, but B is greater than A, but less than 2009. Forms a geometric sequence with an integer ratio. What is A? Okay, so if there's A, B, and 2009, right, and then it says it forms a geometric sequence, right? So A would just be A, B would be A times D, 2009 would be A times 2D, right? No, A times D squared, right? So 2009 equals AD squared, and so to find out what A and D is, we have to dissect 2009. So 2009 is divisible by 7, I think, since 7 and 49 are here. So let's go with 7. 7 and then 2, 14, 60, 7, 8, 56, 49, so 287. So this is, we can also see that this is divisible by 7, since this is divisible by 7 and this is just 7 itself. So this is 7 times 41, and 41 is a prime number, so we can say that A equals 41 and D equals 7. We wanted to know what A is, so A is 41, so the answer is B. Number 10, ABC has a right angle at B. Point D is the foot of the altitude from B. AD equals 3 and DC equals 4. What is the area of ABC? Okay, so if we say that length BD is X, then this triangle and this triangle, they are similar, right? So X to 3 equals, so X to 3 equals 4 to X squared. Okay, so X squared equals 12. So X is 2 root 3. So what is the area of ABC? So the area is AC times BD times 1/2, right? Since they are perpendicular. So AC is 7. BD is 2 root 3 times 1/2. So these two cancel. This is 7 root 3. The answer is B. Problem number 11. One dimension of a cube is increased by 1, another is decreased by 1, and the third is left unchanged. The volume of the new rectangular solid is 5 less than that of the cube. What was the volume of the cube? Okay, so there was a cube. Its dimensions were, let's say, A, and A. So the volume was a cubed. And then one dimension is increased by 1, so, and another is decreased by 1, right? So it will be something like, I don't know, like this maybe, and then this will be A plus 1, A minus 1. So the volume will be A times A minus 1 times A plus 1. But we know that this is A times A squared minus 1, right? So this is A cubed minus A, and then this is 5 less than that of the cube, right? So the cube was A cubed, this was A cubed, and the 5 less than that, so minus 5. Here we can see that 5 equals A. So what was the volume of the cube? This equals 5 squared, since A equals 5. So this is 125. The answer is D. Number 12, in quadrilateral ABCD, AB equals 5, BC is 17, CD is 5, DA is 9, and BD is an integer. What is BD? Okay, so if AB is 5, BC is 17, CD is 5, DA is 9, and BD is an integer. Okay, so we need the triangle inequality, right? And so if this is X, then 5 plus X always has to be greater than 17, and 9 plus 5 always has to be greater than X. So with this one, X has to be greater than 12, and with this one, X has to be less than 14, and X has to be an integer, right? So the only thing that X can be is 13. The answer is C. Number 13, suppose that P equals 2 to the mth power and Q equals 3 to the nth power. Which of the following is equal to 12 to the mnth power for every pair of integers m, n? So 12 to the mnth power equals 3 to the mnth power multiplied by 4 to the mnth power, right? And so this is 3n actually to the mth power multiplied by 4 multiplied by 2m to the 2nth power, right? So this is 3n is q, so this is qm power multiplied by 2m is p, right? P to the 2nth power. The answer is p2 and qm. P2 and qm. So the answer is E. Number 14, four congruent rectangles are placed as shown. The area of the outer square is 4 times that of the inner square. What is the ratio of the length of the longer side of each rectangle to the length of a shorter side? Okay, so if we don't know at first glance, then we can say that this is A, and this is B. Then this will be A plus B, right? So 2A plus B squared is 4 times, right? So 4B squared, 4A squared plus 4A squared plus 4AB plus B squared equals 4B squared. 4A squared plus 4AB minus 3B squared equals 0, right? So it's 4, 1, and then 4, no, so it's 2, 2, and then 3, 1, so it would be like this. A equals 1/2 B, and A can't equal like minus negative, and or A equals -3/2 B, but then since A and B both have to be positive, this is impossible, so A equals 1/2 B. So this means that 2A equals B. So if we switch off B to 2A, then the length of the longer side of each rectangle to the length of the shorter side. So that means that this would be the top is A, right? So it's A, and this is A plus 2A. This is 3A. So the ratio of the length to the shorter side is 3A over A. The answer is 3. But if you but then there's like a different way, and it all starts from this 4 times that of the inner square. So the outer square is 4 times that of the inner square, and then that immediately, and then if that immediately reminds you of this kind of grid-like square, then you are absolutely correct, because these lines, I'll put them in red. These lines are actually the same thing as these lines, right? And so you can immediately see that the rectangle like this has a length of 1 to 3, and so A could immediately pop out. That's another way, and this and you could solve it like way faster if you can see that this is able to be divided into this grid-like format, right? And yeah, and the answer was 3. Moving on to the next problem. Problem 15, the figures f1, f2, f3, and f4 shown are the first in a sequence of figures for n is greater than or equal to 3. Fn is constructed from Fn minus 1 by surrounding it with a square and placing one more diamond on each side of the new square than Fn minus 1 had on each side of its outside square. For example, figure F3 has 13 diamonds. How many diamonds are there in figure F20? Okay, so let's separate it by rings, right? So F1 has only one ring. F2 has this and this. F3 has 1 plus 4 plus 8. F4 has 1 plus 4 plus 8 plus 12. Okay, so it will be 1 plus, so the sequence will go 1 plus 4 plus 8 plus 12 plus, and then it will go on multiplying by 4, no, adding 4, 16, 20, and then this is, and so we know that until this is F1, this is F2, until here is F3, until here is F4, and so we can say that Fn, this is 1 plus 4 times 1 plus 2 plus 3 plus all the way to n minus 1, right? So this is, so if we put in F20 here, F20 equals 1 plus 4 times 1 plus 2 plus 3 plus all the way to 19. This is 1 plus 4 times 19 times 20 over 2. So this is 1 plus 4 times 19 times 10. This is 1 plus 19 times 4 is 76. So this is 760. The answer is 761. So the answer is E. Problem number 16, let A, B, C, and D be real numbers with A minus B equals 2, B minus C equals 3, and C minus D equals 4, all with what did you call these? Absolute values. Yeah, right. What is the sum of all possible values of the absolute value of A minus D? Okay, so from this one, we have two choices, kind of. So A is B plus 2, or A is B minus 2. And then from this one, B equals C plus 3 or C minus 3. From this one, we can see C is D plus 4 or D minus 4. So A minus D, let's say, so let's just put these into here and put these into here, right? So if we do that, then we get a lot of different values, right? And so we could get that A is Yeah, right. So if B is C plus 3 and B plus 2, then A equals B plus 2 and then plus 3, right? So C plus 5, because these two are together. And then, or this could be B plus 2 and C minus 3, right? So this could be C minus 1, and it could be this and this. So it could be C plus 1, and it could be this and this. So it could be C minus 5. And then, putting these two into each of these in turn, then we will be able to see that, oops, like that, yeah. And so we would be able to see that if this is put in here, then this is D plus 9 or D plus 1, and then this is D plus 3 or D minus 5. This is D plus 5 or D minus 3. This is D minus 1 or D minus 9. So from here, we can see that A equals D plus 9, D plus 1, D plus 3, D minus 5, D plus 5, D minus 3, D minus 1, and D minus 9. But then, what we want is the absolute value of A minus D, right? So if we move all these D's onto the other side of the equal sign, right? And so this would be, these would all come here, and then it would become minus, right? So A minus D equals this, or this, right? But then it might look like there are 8 values, but then we have the absolute value sign, right? So this is absolute value of everything, right? And so what this would mean is that this is 9, 1, 3, 5, 5, 3, 1, 9. So these two are the same, these two are the same, these two are the same, and these two are the same. So this is 9, 1, 3, and 5. This is what it all boils down to. And the sum of all possible value is 9 plus 1 plus 3 plus 5, which is 18. The answer is D. Problem number 17. Rectangle ABCD has AB equals 4 and BC equals 3. Segment EF is constructed through B so that EF is perpendicular to DB, and C and A and C lie on DE and DF respectively. What is EF? Okay, so let's have a rectangle. So this would be 4, this would be 3, and the segment EF is constructed through B. Okay, so let's say that there's a line like that, and then a line like that. And so EF has to be perpendicular to DB, right? So if we put in DB, this is DB, and this has to be perpendicular to that, right? So it would be something like this. Yes, like that. So it would be like this. This would be A and C line on DE and DF, right? So this would be E and this would be F. So AB is 4 and BC is 3. What is EF? So since this is 4 and this is 3, we can know from the Pythagorean theorem that this is 5, right? 5 here. And then since these triangles and this triangle and this triangle and this triangle, they are all similar, right? So using the similar triangles, we can say that EB equals 5 times 4 over 3, and because of this triangle right here. And BF, not E, BF would be 5 times 3 over 4 because of this triangle here. So this is 20 over 3. This is 15 over 4. 20 over 3 plus 15 over 4 equals over 12, and then this will be 80 plus 45. This is 125 over 12. So the answer is C. Problem 18. At Jefferson Summer Camp, 60% of the children play soccer, 30% of the children swim, and 40% of the soccer players swim. To the nearest whole percent, what percent of the non-swimmers play soccer? Okay, so let's say that there are 100 people in total at the camp. So 60 people play soccer, 30 people swim, and of the 60 people, 40% swim, right? So 6 times 4 equals 24. So 24 people swim out of these. So 24 swim and play soccer. And so 60 minus 24 equals 36, right? 36 would play soccer but not swim, right? And so what percent of the non-swimmers play soccer? Okay, so if 30% swim, so if 30 people swim, 70 people will not swim, right? They will not swim. And of the people that not swim, so out of 70, what percent play soccer? So it's 36 people that play soccer, but they not swim. So this is 36. It's 70 over 36. 36 over 70. This is 5. No. This is 0.05 and 350, 100, 170, 300, 4, and so this would be like this. So this would be 51.4 something percent. So it's to the nearest whole percent, right? So the answer is 51%. It's D. Problem 19. Circle A has radius 100. Circle B has integer radius. R is less than 100 and remains internally tangent to circle A as it rolls once around the circumference of circle A. So we have a circle and it has radius 100. So the radius is 100. And then we have circle B, like that. And then this is like this. It's tangent to the circle A, and it rolls once around like this. And then the two circles have the same points of tangency at the beginning and end of circle B strip. Okay, so what this means? So this means is that the circumference of circle A is a multiple of the circumference of B, right? And so this is the circumference of A, so we can know that, right? Since circle A has radius 100, so circumference of A 200 pi. This is a multiple of circumference of B. Okay, so if circle B has radius of R, then this is 2 pi R times something, right? So 100 equals R times something. So R is a factor of 100, and the factors of 100, how many are there? 100 equals 2 squared times 5 squared, so this is 2 plus 1 and 2 plus 1, so it's 3 times 3, so this is 9. So there are 9 factors of 100, right? But then we have to keep in mind that R has to be less than 100, so R cannot be 100, so we have to subtract 1 from 9, so 9 minus 1 equals 8. The answer is 8, so the answer is B. And number 20, Andrea and Lauren are 20 kilometers apart. They bike toward one another, with Andrea traveling 3 times as fast as Lauren, and the distance between them decreasing at a rate of 1 kilometer per minute. So it says that the distance decreases at 1 kilometer per minute, right? But then Andrea is traveling 3 times as fast as Lauren, so that must mean that Andrea is traveling 3 over 4 kilometer per minute, and Lauren is traveling 1 over 4 kilometer per minute, right? Since that's the only way that these could add up to 1 kilometer and still have Andrea be 3 times as fast as Lauren, right? But then after 5 minutes, Andrea stops biking because of a flat tire and waits for Lauren. About how many minutes from the time they start the bike does Lauren reach Andrea? Okay, so it says after 5 minutes, right? So 5 minutes of going 1 kilometer per minute, right? 1 kilometer per minute, so it went 5 kilometers. So 15 kilometers left, and then speed is 1 over 4 kilometers per minute. Since she's just waiting for Lauren, Andrea is just waiting for Lauren, so it's 1 over 4 kilometer per minute. So 15 divided by 1 over 4, this is 60. So it takes 60 minutes, 60 more minutes for Lauren to reach Andrea. But then we can't forget the 5 minutes that elapsed at the first time, right? So it's 5 plus 60, 60 from here, equals 65. The answer is D. Problem 21. Many Gothic cathedrals have windows with portions containing a ring of concurrent circles that are circumscribed by a larger circle. In the figure shown, the number of smaller circles is 4. What is the ratio of the sum of the areas of the 4 smaller circles to the area of the larger circle? Okay, so if we say that the radius is r, so the radius of the small circle is r, then we can connect the midpoints of the 4 circles, right? So we can connect the centers, and then they will form a good square. And since the square's one side is two of the radiuses, this will be 2r. So radius would be 2r, and then from this point, so from the center of the big circle to the center of one of the smaller circles, this would be root 2r, right? Because this multiplied by root 2 is 2r, so this will be root 2r. But then we also know that this is r, right? So this much is r. So the radius of the larger circle, this will be root 2r plus r. This is root 2 plus 1r. And the radius of the smaller circle is r, as we know, right? And then the areas of the 4 smaller circles to the area of the larger circle, right? So we have to find the ratio of this. So the smaller circles, this will be 4 times pi r squared, and the large circle would be root 2 plus 1 squared times pi r squared, right? So this is 4, and then this is root 2 plus 1 squared, which is 3 plus 2 root 2, right? So the answer is 4 over 3 plus 2 root 2, but then we could multiply 3 minus 2 root 2 to both up and down, to both the denominator and the numerator, and this would be like this. And so this will become 1, and then 4 times 3 minus 2 root 2, so the denominator 1 just goes away, and so what we have left is this thing, and the answer is C. Problem 22. 2 cubical dice each have removable numbers 1 through 6. The 12 numbers on the 2 dice are removed, put into a bag, then drawn one at a time and randomly reattached to the faces of the cubes. One number to each face. The dice are then rolled, and the numbers on the 2 top faces are added. Okay, so this much of the text is just a fancy way of saying there is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and then we are picking 2 of them and then adding them. So the dice are then rolled and the numbers on the 2 top faces are added, right? What is the probability that the sum is 7? So the sum is 7. That's what we want to know. And for the sum to be 7, then we need a 1, 6. So it could be 1, 6. Could be these 2, or these 2, or these 2. So 1, 6 could be these 2, or it could be these 2, or it could be these 2, or it could be these 2, right? So there are 4 ways. And then same thing with the 2 and 5. So this can also be 2 plus 5, right? So this is the same thing. 1, 2, 3, 4, 4 ways. And the same thing for 3 and 4. This is also 4 ways, right? And then so this would be equal to 4 times 3, right? 4 times 3 over, and then we have 12 choose 2. 12 choose 2. This is 12 times 11 over 2. This is 66. This is 12 over 66, which is 2 over 11. The answer is 2 over 11, which is D. Problem number 23. Convex quadrilateral ABCD has AB equals 9 and CD equals 12. Diagonals AD and BC intersect at E. AC equals 14 and AED and BEC have equal areas. Okay, so let's draw this quadrilateral. If it's shaped like this, and if this is AB, if this is A, B, C, D, this is 9, this is 12, and then AC and BD, right? So they're the diagonals. There's AC and there's BD. And then they intersect at E. This would be E, right? And AC equals 14. And AED and BEC have equal areas. Okay, so this is the key point. This triangle and this triangle, they have equal areas. And what that can only mean is that this must be an isosceles trapezoid. Because those have the same area for both triangles at either end like this. So if we make an isosceles trapezoid again, it would be like this, like this, like this, and then this would be, and this would actually be what ABCD looks like that, oh, like that, and then that would be ABCD. This is an inaccurate picture. This would be A, B, C, D. This is 9, this is 12, and then this much is 14, and then they have equal area. So if this is 9 to 12, then this triangle and this triangle would be similar, right? So the ratio would be 3 to 4, but the whole thing is 14, right? So if the whole thing is 14, then this would be, if this is E, right? So AE equals 3 over 7, because the whole thing is 7, and this is 3 of it, multiplied by AC equals 14, which is 6, and then EC equals 4 over 7 times 14, which is 8, so this is 6 and this is 8. What is AE? So all we wanted was AE, the answer is 6, so it's E. Number 24, 3 distinct vertices of a cube are chosen at random. What is the probability that the plane determined by these 3 vertices contain points inside the cube? Okay, so we have a cube like this, and then we have 8 vertices, as always, and then we are choosing 3 of them, so the bottom line will be 8 choose 3, right? And then the plane determined by these 3 vertices, so what that means is basically if we have like if we choose these 3 vertices, then the plane determined by them would be this plane right here. And then this would contain points inside the cube, since all these points are inside the cube. But then an example of a vertices that make a point that's outside the cube would be like these 3, right? And these 3 would make the plane only surface. So it wouldn't contain any points inside the cube, and it will only be on the surface, right? And so that's the kind of thing I'm talking about. So first of all, the bottom line is 8 choose 3, and for the numerator, first let's look for how many 3 like chosen points can have a plane with points outside the cube, so no points inside the cube. So that could be arranged by choosing 3 points that are all on one face, right? And so there are 6 faces, and then there are 4 ways to like choose 3 of the 4 vertices, right? So there could be this, there could be this, there could be this, and there could be this. So there are 4 ways. This is 24 over, and then 8 choose 3. This is 8 times 7 times 6 over 6. So this would be just 8 times 7, 56. This is 7 over 3. And then what we want is the points inside the cube, right? So this is the whole thing. So the total probability is 1 minus not inside the cube, which is 3 over 7. So 1 minus 3 over 7 equals 4 over 7. So the answer is 4 over 7, and it's C. And the last problem for k is greater than 0. Let ik equals 10, 1, 0, 0, 0, 0, 0, 0, 0, all the way up to 64, where there are k zeros between the 1 and the 6. Let nk be the number of factors of 2 in the prime factorization of ik. What is the maximum value of nk? So first, let's separate this into 64 plus 1, 0, 0, 0, 0, however many zeros there will be, so that there will be k plus 2 zeros, right? And 64, as we all know, is 2 to the 6th power, and this much would be 2 to the k plus 2nd power times 2 to the times 5 to the k plus 2nd power, right? And then, so what is the maximum value of nk, right? And so if k equals 4, then this would be 2 to the 6th plus 2 to the 6th times 5 to the 6th. This would be if 2 to the 6th is like if it's taken out, then 2 to the 6th times 1 plus 5 to the 6th power, and then well, obviously you would have 2 to the 6th power here. You also have one more 2 that's sitting in here, because both 1 is odd, because 1 is odd, and 5 to the 6th power is also odd. So when they are together, they will become even, right? So this is 2 to the 6th power plus one more power of 2, because this is even. So this is 2 to the power of 7 times something, right? And so the maximum value of nk would be this. So it's 7. The answer is B. That was problem 25, and thank you for watching.